triple identity. So the first one is sine. So the first is sine 3x. So as you can see, 3x is x plus 2x. And from our additional identity, we know that sine a plus b sine a cos b plus cos a sine b. So we are going to, so we have, this is now sine x cos 2x plus cos x sine 2x. That's from our additional identity. So, but we've known that cos 2x from our double angle identity is, okay, we have three expressions for that. We have the first one, the second, and the third. But since we are on sine, so we're going to use the identity that has sine only. So cos 2 is equal to this. It could be this and this, but we are on sine, so we choose this. So we now have that sine x for this x. So cos 2x is now 1 minus 2 sine squared x from our double identity, plus cos x also from our double identity sine 2x, or 2 is now 2 sine cos. So this is 2, this is now 2 sine x cos x. So expand the brackets. Sine x times 1 is sine x. Sine x times 2 sine squared x is minus 2 sine cube x. Plus cos x, okay, we can multiply, which is now 2 sine x cos squared x. So again, we're on sine, so we need to write cos in terms of sine. So from our Pythagorean identity, we know that sine squared x plus cos squared x is 1. Sine squared x plus cos squared x is 1. So which implies that cos squared is now 1 minus sine squared x. That's from our Pythagorean identity. So we still open up. This is minus 2 sine cube x plus 2 times, that is 2 sine x. This time that is minus 2 sine cube x. So we can now collect like terms. Sine x plus 2 sine x is 3 sine x. Y minus 2 cube minus 2 sine cube x minus 2 sine cube x is minus 4 sine cube x. So this is our identity for sine 3x. As the triple identity is equal to this. So again, for cos is, that's 3x is x plus 2x, and using our additional identity, we know that cos x plus 2x is cos x cos 2x minus sine x sine 2x. So remember, okay, from this, let me show you. As cos a plus b is cos a cos b minus sine a sine b. If it's plus minus, if it's minus plus, so cos cos sine sine. So looking at what I've written, so it's the same. So cos cos sine sine minus, because we have plus here, so which will expand to, from our double identity, I told you cos 2x has three values. The first one is this, the second one is that. We use this that first time for sine because we're on sine. So since we're on cos, we use the one that has only cos. So we now replace cos 2x with 2 cos squared x minus 1. That's our cos 2x minus sine x. We've known that sine 2x is 2 sine x cos x. So we open up. Cos x times 2 cos squared x is 2 cos cube x. Cos x times that is minus cos x minus sine. Okay, we can multiply the which is now minus 2 cos x sine squared x. Or we can multiply it. So we'll continue. So again, since we're on cos, we need to write sine in terms of cos. So from our Pythagorean identity, we replace sine with cos. That sine squared is now 1 minus cos squared. So we still open up. 2 times 2 cos x times 1 is 2 cos x minus 2 cos x times that is plus 2 cos cube x. So we'll collect like terms. 2 cos cube x plus 2 cos cube x is 4 cos cube x minus cos x minus 2x is minus 3 cos x. So that's our triple identity for cos. So very important. So finally for tan, so we know that 3x is x plus 2x, and from our addition formula for tan is equal to tan x plus tan 2x over 1 minus tan x times tan 2x. So that's our addition formula for tan, as you can see from our previous video. Tan a plus b is that, so we just replace. We have x and 2x, so a is x, b is 2x. So we open up by substituting the value of tan 2x. We have from our double identity for tan 2x is 2 tan x over 1 minus tan squared x. So that's it from our double identity. Let me show you. See it, tan 2a is 2 tan a 1 over 1 minus tan squared. So our a here is x, so substitute. So over 1 minus tan x, 2 tan x over 1 minus tan squared x. So we'll continue. So the LCM is, so I'll write this as our common LCM is 1 minus tan squared x. That's the LCM of 1 and that, and 1 and 1 minus tan squared x is that. This in this is 1 times that, so we'll have tan x times 1 minus tan squared x plus 2 tan x. So this divided by this 1 times that. So that's our numerator divided by our denominator again is 1 minus tan squared x. This in 1 is that, so times 1 is also 1 minus tan squared x. This in this is 1 times that, so we can multiply this, so this is minus 2 tan squared x. So that's our denominator. So this divided by this, we now have that, you know, they have common denominator, this and this, so this becomes the numerator of the result, why this becomes the denominator. So we can open up. Tan x times 1 is tan x, tan x times that is tan cube x plus 2 tan x divided by, because they have common, I've reduced the thing, divided by that 1. So we can add up. So this is 1 minus 3 times squared x. So yes, and we can still add tan x minus tan x plus 2 tan x is 3 tan x. So therefore this equal to 3 tan x minus tan cube x over, you get tan x plus this is 3 tan x minus that over 1 minus 3 times squared x. So this is our identity for triple identity for tan. So let's use it and solve a question, or maybe 2 or 3 questions. Okay, look at this. With what we've learned, let's use it and solve this question. We're asked to evaluate the following without calculator. Okay, the first question is this. The first thing I notice, what is here is here is here. So you know I can write this as minus 1 minus 3 tan squared 15 over minus 3 tan 15 minus tan cube 15. So that's the thing. Nothing has spoiled. Minus 1 times minus times 1 is minus 1. Minus times this is that. This times this is this. Why this times that is that. So we are getting to something. So minus divided by minus is positive. And as you can see, I can write this once I reciprocate. So I can write this as 1 over 3 tan 15 minus tan cube 15 over 1 minus 3 tan squared 15. And as you can see, look at our identity. You can easily see that this thing means tan 3 times 15. Yes. 15 degrees. Yes. Look at our identity from our triple identity. You see that tan 3, I really see that 3 tan x. You can easily see that tan 3x is 3 tan x minus tan cube x over 1 minus 3 tan squared x. So compare it with this, they are the same. So see it, 3 tan x minus tan x cube x over 1 minus 3 tan squared x. So our x is 15. So it's a tricky one, but it's simple. So which is the same as tan 45. So which is equal to, we know that tan 45 is 1. So the answer is 1 over 1, which is 1. So it's a tricky one. So the second one, this one is direct, because as you can see from our triple identity for sine, sine 3x is 3 sine x minus 4 sine cube x. So 3 sine x minus 4 sine cube x. So our x is 10. So the answer, this is just, so this 3 sine 10 minus 4 sine cube x, which is 10, is equal to sine 3 times 10. So this is sine 30. So the answer is half. So coming to the last one, this looks like our triple identity for cosine, as you can see. Cos 3x is 4 cos cube x minus 3 cos x cos us. But this one has sign. The equation has sign, but and again, you know, this is xx. So look at this. So you can easily, this is 4 cos cube x minus should be 3 cos x. But if you remember our cofunction identity, yes, cofunction identity says that sine x is equal to cos 90 minus x, or cos x equal to sine 90 minus x. So the sum of these two angles must be 90. So looking at this, we can change this 4 cos cube x, which is cos 25, minus 3 sine 75. We can still change sine 75 as cos, so which is now 3 cos 25 from what I just said here. So the sum is 9, so which is now the identity, the triple identity for cosine. So see, it costs, so what is here is here, as you can see, 25 25. So our answer is just cos 3 times 25, so which is cos 3 times 25. This is cos 75, and remember we are not asked to use calculator, so we need to continue. Cos 75 is a combination of 30 and 45, so this is cos 30 plus 45. So using our addition identity, which is cos 30 cos 45 minus sine 30 sine 45, our addition identity for as our first video for cosine. See it, cos a plus b is cos a minus sine a sine. So since it's positive here, it's negative, so we'll continue. So this is cos 30 is root 3 over 2, cos 45 is root 2 over 2, minus sine 30 is half, sine 45 is root 2 over 2. So this is root 3 times root 2 is root 6 over 4, minus 1 times root 2 is root 2 over 4. So that's our answer. So the questions are very tricky but very simple. Thank you.